The illusion of control. There is a famous story from 1927. The greatest minds in human history gathered at a hotel in Brussels for the Solvay Conference. Albert Einstein was there. Niels Bohr, Marie Curie, Schrödinger. They sat in a room and argued about the nature of reality. Einstein looked at the chaos of quantum mechanics, a world where things can be in two places at once, where cause and effect seem to break down, and he refused to accept it. He famously said, "God does not play dice with the universe." He believed the universe was orderly, predictable, like a clock. Niels Bohr looked back at him and said, "Einstein, stop telling God what to do." For the last 100 years, we have built our entire civilization on Einstein's clock. Our computers, our phones, our internet, they are all machines of order. They follow strict rules. 0 or 1, yes or no, true or false. We built a digital world based on certainty, but Bohr was right. Deep down, beneath the screen you are looking at, beneath the chair you are sitting on, beneath the atoms of your own skin, the universe is not a clock. It is a chaotic, swirling ocean of probability. It is a place where impossible is just a number. And for a century, we stood on the shore of that ocean, afraid to dip our toes in. Until now. Welcome to the Quantum Files. Today, we are not just talking about a faster computer. We are talking about the moment humanity decided to stop building clocks and started trying to build a universe. We are going to explore the machine that will cure disease, reverse climate change, and destroy privacy as we know it. This is the story of the quantum computer. And it begins with a simple, terrifying realization: we have hit the wall. Chapter I, the Silicon Graveyard. To understand why the quantum revolution is inevitable, you first have to understand the death of the tool you are using right now, the transistor. The transistor is the greatest invention of the 20th century. It is a simple switch. It stops electricity 0, or it lets it flow 1. By combining billions of these switches, we created the modern world. For 50 years, we followed a prophecy called Moore's Law. We made the switches smaller and faster. We went from switches the size of a thumb to switches the size of a virus. But nature has a speed limit. Right now, the most advanced chips in the world, manufactured by TSMC or Intel, have transistors that are just a few nanometers wide. That is barely the width of a strand of DNA. We are pushing the atoms so close together that the electrons are starting to panic. When you make a wall that thin, classic physics stops working. The electron doesn't stop at the wall. It magically teleports through it. This is called quantum tunneling. For a classical computer, this is fatal. The switch leaks. The logic fails. The computer crashes. We cannot make SILA chips much smaller. The era of classical advancement is ending. If we want to solve the problems of the 21st century, problems like climate modeling, protein folding, or interstellar navigation, classic computers simply aren't strong enough. If we tried to use a classic supercomputer to perfectly simulate a simple caffeine molecule, just coffee, it would take longer than the age of the universe. Why? Because nature isn't binary. Nature is quantum. To simulate nature, we needed a machine that speaks the language of nature. And that required us to do something insane. It required us to harness the very thing that Einstein feared. Chapter 2, the chandelier in the void. If you walk into the quantum labs at Google in Santa Barbara, or IBM in New York, you won't see a black box or a glowing screen. You will see something that looks like it belongs in a cathedral, or an alien spacecraft. They call it the chandelier. It is a twisting, golden structure of copper and gold-plated pipes, hanging from the ceiling. It is stunningly beautiful. But its beauty has a function. This structure is the most sophisticated refrigerator ever built. At the very top, it is room temperature. But as you travel down the gold pipes, it gets colder and colder, until you reach the tiny chip at the very bottom. At that point, the temperature is 15 millikelvin. That is colder than the dark side of the moon. It is colder than the deepest void of outer space. It is almost absolute zero, the point where all atomic motion stops. Why? Why do we need to freeze this machine? Because the qubits, the quantum bits that power this machine, are the most fragile things in the universe. A classical bit is like a rock. You can throw it, heat it, drop it, and it remains a rock. A qubit is like a soap bubble floating in a hurricane. A qubit relies on a state called superposition. Imagine a spinning coin. While it is spinning, is it heads? Is it tails? No. It is a mixture of both. It is in a state of probability. A classical computer reads the coin after it lands, heads or tails. A quantum computer uses the coin while it is spinning. This allows it to hold massive amounts of information simultaneously. If you have 2 qubits, you can hold 4 states at once. If you have 3, you have 8. It grows exponentially. By the time you have just 300 perfect qubits, you can hold more simultaneous states than there are atoms in the observable universe. Think about that. A chip the size of your fingernail could contain a mathematical map larger than the entire cosmos. But here is the catch. The moment the wind blows, the coin falls. The bubble pops. If a single photon of light hits the qubit, or a tiny vibration from a truck driving a mile away shakes the room, the superposition collapses. The magic is lost. This is called decoherence. That is why the chandelier exists. It is a coffin designed to protect the ghost inside from the noise of the real world. We are trying to maintain a state of existence that nature usually forbids. We are playing God with atoms, and when we succeed, the results are terrifying. Before we open the door to what this machine can actually do to your life, a quick question. The content you are listening to right now, these deep dives into the future of humanity, is not powered by an algorithm. It is powered by curiosity. By people like you who want to understand the why behind the what. If you want to stay ahead of the curve, if you want to know about the technologies that will define the next decade, before they hit the mainstream news, do me a favor. Click that subscribe button on the Quantum Files. Turn on the bell. We are building a community of thinkers here, not just viewers. Join us. Now let's talk about why the CIA and the NSA are terrified of this machine. Chapter 3. The End of Secrets Y2Q. In 1994, a mathematician named Peter Shor walked into Bell Labs and essentially broke the internet. He didn't use a hammer, he used math. He created Shor's algorithm. He proved that if you had a functional quantum computer, you could break RSA encryption. RSA is the lock on the digital world. It protects your bank account, your medical records, your emails, and the nuclear launch codes of superpowers. It is based on a math problem involving prime numbers that is so hard, it would take a classical supercomputer trillions of years to solve. Shor showed that a quantum computer could find the answer, not in trillions of years, but in hours. This moment is known in the intelligence community as Y2Q. The year to quantum. It is the day the walls fall down. Imagine a world where encryption no longer exists. You wake up, and every text message you've ever sent is public. Every trade secret of Apple and Coca-Cola is downloadable. Every spy network is exposed. The banking system collapses because no transaction can be verified. It sounds like fiction, but governments are treating it as an imminent threat. In fact, there is a strategy happening right now called Harvest Now, Decrypt Later. Hackers and state-sponsored agencies are stealing encrypted data today. They can't read it yet. It looks like gibberish. But they are storing it in massive data centers. They are hoarding it, waiting for the day the quantum key is forged. 5 years from now, 10 years from now, when the machine turns on, the archives of the past will unlock. This is why the race between the US and China for quantum supremacy is not a friendly science fair. It is an arms race. It is the Manhattan Project of the 21st century. Whoever builds a stable quantum computer first holds the master key to the entire digital infrastructure of the planet. But, while the generals and spies are worrying about destruction, the biologists and chemists are dreaming of creation. Chapter 4. The Alchemist's Dream. Let's step away from the darkness for a moment. Because the true potential of quantum computing isn't about breaking things. It's about building things that have never existed. It is about simulation. For thousands of years, human chemistry has been based on trial and error. We mix things in a beaker, heat them up, and see what happens. It is slow. It is messy. We do this because we cannot simulate chemistry. The interaction of electrons in a molecule is too complex for a classical computer. But a quantum computer, it doesn't just simulate the electrons, it mimics them. Let me give you one concrete example that could save the world: nitrogenase. Nitrogenase is a tiny enzyme found in the roots of plants. It does something miraculous. It pulls nitrogen out of the air and turns it into ammonia fertilizer at room temperature. It does it effortlessly. Humans, we have to use the Haber-Bosch process. We build massive factories, use extreme heat and pressure, and burn 2% of the world's entire energy supply just to make fertilizer to feed the planet. We know nitrogenase works, but we don't know how. We can't see the quantum dance of its atoms. A quantum computer could model this enzyme perfectly. It could give us the blueprint to build artificial nitrogenase. Overnight, we could slash global carbon emissions. We could produce fertilizer from thin air, anywhere in the world for free. The hunger crisis, solved. And that is just the beginning. Think about medicine. Right now, developing a new drug takes 10 years and billions of dollars, because we have to test it on animals and humans, to see how the proteins fold. A quantum computer could simulate the biology of your specific body. We could design a cancer drug that targets only your tumor, shaped perfectly to fit your DNA, with zero side effects. We are talking about personalized medicine. We are talking about materials that can capture carbon directly from the atmosphere. We are talking about room temperature superconductors that would revolutionize energy transmission. We are moving from the age of discovery to the age of design. We will no longer have to search for cures. We will compute them. Chapter 5. The Quantum Internet, the Shield. So, we have a paradox. We have a machine that can destroy all secrecy, but also save the planet. How do we survive the transition? The answer lies in the physics itself. To fight a quantum sword, you need a quantum shield. Scientists are currently building the quantum internet. This is not just faster Wi-Fi. This is a communication network that is physically impossible to hack. It relies on the principle that observation changes reality. In the quantum world, you cannot look at a particle without changing it. So, if I send you a message encoded in quantum particles, and a hacker tries to intercept it, the act of him looking at the message destroys the message. The spin of the photons changes. You and I will know instantly that someone is listening. It is the ultimate security. Privacy guaranteed not by math, but by the laws of the universe. We are already testing this. Banks in Switzerland, satellite networks in China, they are laying the groundwork for this new web. The future isn't just about faster processing. It is about a fundamental split. The old internet will be a public square, open and vulnerable. The quantum internet will be the vault, where true value moves. We are standing on the edge of an event horizon. Most people look at technology as a straight line. Better phones, faster apps, clearer screens. But quantum computing is not a step forward on the line. It is a jump to a new dimension. It challenges our philosophy. It forces us to accept that the solid reality we see is an illusion, and that at the bottom of everything, there is only probability and connection. It challenges our security. It forces us to rethink what privacy means in a transparent world. And it challenges our ambition. It gives us the power to act as architects of nature, to weave atoms together into materials that have never existed in the history of the stars. The machine in the chandelier is waking up. The noise is quieting down. The qubits are stabilizing. The question is not will it happen. The question is, are you ready? Ready for a world where the impossible becomes the standard. Ready for the quantum age. Thank you for venturing into the deep with us today. This is just the first file in our series. Next time, we are going to open the file on synthetic consciousness. What happens when we give a quantum brain to an AI? If you found value in this journey, leave a comment below. Do you think the quantum future is a utopia or a dystopia? I read every single comment. Don't forget to like, subscribe to Quantum Files, and share this video with someone who needs to wake up. Until next time, stay curious.